Hello everyone. In this lecture, I'll be discussing data types, variables, and modules and their definitions. This is chapter 2 from our first textbook, Fundamentals of Python. Learning objectives include data types, variables, and assignments, and how we can add comments or name our variables, arithmetic expressions, and functions and modules in Python. A data type consists of a set of values and a set of operations that can be performed on those values. In this table, you can see the three popular types of data: integers, real numbers, character strings. The Python syntax for integers is int, short form of integer. Real numbers, we use float, and for character or strings, we use str. And in the third column, you will see some examples. So let's play with the strings, character strings. So here you can see two lines of code. We want to print a statement. And when we use quotation marks, as you can see here, it means everything will be printed as you see. So the first statement is going to open a Jupyter notebook and just copy and paste that line of code. Print, and then parentheses, the quotation mark. Please pay attention to colors. When you are using reserved names or built-in statement like print, the color is green. And when you use the quotation mark, the color is brown. So print, my grade will be A in DSA 5970. So if you run this, you see the exact sentence. My grade will be A. And now let's say you want to add another line. So in second line, you will see that I have added a backward /n. It means that it goes to the next line. If you run this code, then you will see my grade will be, and then the rest appears in the next line. So my grade will be A in DSA 5970. And we use this just to print the output of our algorithm. And sometimes we prefer to present it in different lines. And you can see the backward /n to go to the next line. The new line character backward /n is called an escape sequence. And here you can see many escape sequences here and with their meaning. Backward /b is used for backspace. Backward /n, as you saw in that example, for new line. Backward /t is horizontal tab. If you want to see the backward /character, you will need to have double backward slashes. And then if you want to see the single quotation mark, you add backward / and the single quotation mark, and the same for double quotation mark. In this example, you want to print that I am 6 feet and 2 inches tall. To do that, if we want to see the single quotation mark and the double quotation mark, we need to add the backward /. For example, here, if you add a new block and then print quotation mark, I am 6 backward / 6 feet, and let's say 5 inches tall. And now you can see the single and double quotations mark in the output. We can join two or more strings to form a new string. It's called a string concatenation, and we use addition sign or the plus sign. So in this example, you will see the first string and the quotation mark we plus another quotation mark will have 3 problems plus another quotation mark in homework 1. And if you run this, you will see one sentence. Again, I would like to draw your attention to colors. Plus sign is like purple, and then everything inside the quotation mark is brown. And when you run this line of code, you will see we will have 3 problems in homework 1. And if you want to see spaces, then you will add space, blank space to the first term, the rest for other terms. Another point under a string concatenation is the asterisk operator, which allows you to build a string by repeating another string a given number of times. Here's an example. So you have the first string I, asterisk operator 10. So it means I times 10. So you are going to see i's 10 times plus Python. So let's run this and see what the output look like. So I asterisk 10 plus Python. And if you run this, you will see 10 i's in the beginning and then Python. These are different ways when you have different outputs. If you want to join them, combine them, so you will use the plus sign. So far we discussed 3 data types: integer, reals, and real numbers, and strings, which is used for characters. Now, variables and assignment. A variable associates a name with a value. For example, A is equal to 10, means that A contains 10. So it just makes it easy to remember and use later in the program. If we want to use that variable several times, we prefer to assign that value to that variable, and each time we just call the variable. There are some rules for naming variables. Reserved words cannot be used as variable names. The reserved word's color is green, so it is like a built-in statement. Here are a few examples. If, for if a statement, define or def when we want to define a function, and import when we want to import a library. So when you type in these words, the color turns green. It means that these are reserved words and we cannot use them to name our variable. Name must begin with a letter or underline sign. Name can contain any number of letters, digits, or underline. The important part is that names are case sensitive. Here's an example. Weight with all upper cases is different from weight with lower cases. Here's a tip. Begin each word in the variable name with an uppercase, except the first one. So this is just a common practice. My suggestion is that you find your style and stick to it. So here's an example. We begin with a lowercase, so interest, and then uppercase for each word. So interest rate. Programmers use all uppercase letters for symbolic constants. Constant contain values that the program never changes. Examples, tax underline rate. It's a constant. Or a standard underline deduction. So tax rate is 0.1, 10%, 20%. So it's a constant, and we usually use all uppercase letters. Variables receive initial values and can be reset to new values with an assignment statement. So here you can see the general format. On the left side is the variable name. So you can choose anything. Just follow the naming rules. Equal to expression. So a variable name equal to 20, then its value is 20. Variables should be initialized in coding. So when you define a variable, you need to assign a value. But its value can be updated in different procedures, and you are going to see several examples. Overall, variables serve 2 purposes. Help the programmer keep track of data that change over time. Because at each time period, the variable's value gets updated, and then you can plot its value over time. It also allows the programmer to refer to a complex piece of information with a simple name, which is called abstraction. So you run a procedure, and then the result is assigned to a variable, and then you just call that variable, and then you have the result. Here is an example. So you can see I have defined several variables. I'm assigning a value, so I'm initializing these variables, and then just subtract them, define a very simple formula, cars underline driven times a space, and I'm calculating average passengers per car. So for each variable, we have the value, the initial values and the calculated ones. Eventually, we want to communicate with the user. We want to print the result. Okay, there are this many cars available. To show the output to the user, we use print statement. And here, let's switch to the Jupyter Notebook so you can see this code here. Again, please pay attention to the color. Cars equal to 100. I define a variable named cars and its value is 100, and the same for other. And then for here, cars underline driven is equal to drivers. So I'm assigning a variable, its value to another variable. And then a very simple formula here. So I run this, nothing. We don't see any syntax error, but also we want to show the results to the user, and that's why we are going to use the print statement. And again, this is a reserved word. The color is green. So print, there are comma, and then we call the variables. So it shows the value for this variable, and then comma, then another string, the rest of our sentence. If you look at all examples here, so print, we need to put about, and then we call the variables, comma, and each car. So if you run this, you can see that the value for the variable shows up here. So there are 100 cars available, or there are only 30 drivers available. And this is what the users see eventually. So in this example, we define some variables. We did a very simple calculation, and then we showed the results to the user with the combination of variables and strings, because we are using quotation marks here. Here's the second example. Now we are going to ask the user to input a value for our variable. And the statement, to do that, we are going to use input statement. Again, we expect that its color turns green because it's a reserved word. Age is my variable. Its value is equal to input, how old are you? It means that I'm asking the user to input their age. And then the value is assigned to age variable. And then height, how tall are you? The value is assigned to height variable. And then weight, how much do you weigh? So its value is assigned to weight. So here, the 2 points, we are defining 3 variables. We are also asking the user to assign the value to each variable. And to do that, we are using input statement. And then we want to show the result. So we are going to use the print statement. And we want to communicate clearly. So you are, then we call age, which is our variable, years old, and the rest for height and weight. Then you will see another piece of code down below. They are the same, but it shows you that there are different ways to print the same result. And it's very important in programming. For a procedure, different programmers can use different techniques for coding. And here you can see 2 pieces of code, but they are the same. So in the second piece, you can see that I'm printing a question. Print, how old are you? And then define my variable equal to input, and whatever the user inputs, then it is assigned to variable age. So first I use print and then input. And there is nothing inside the parentheses. Again, when you use the same print statement, the result would be the same, just two different ways. Now let's take a quick look. Let's try to run these two pieces. So age equal to input, height equal to input. So you can see the color, reserved word, and then the print statement. So let's run this. You can see the first question, how old are you? Let's say 55. And then you press enter. Now 55 is assigned to variable age. How tall are you? Let's say 5 feet and 9 inches. Press enter. How much do you weigh? Let's say 167 pounds. And then you see the result. So you are 55 years old, 5 feet and 9 inches. So I needed a single quotation mark. Tall, and then 167 heavy, your weight. Here, in this block, you can see the second piece. So let me run this. So it starts with a print statement and then the variable with the input statement. How old are you? Let's say 45. How tall are you? 5 feet and 9 inches. Press enter. How much do you weigh? 145 pounds. And you can see that the results are the same. It's just two different ways to produce the same result. So far we played with input statement, print statement, define different variables, assign values to them, and then we showed the result using the print statement to the user. Now, program comments. Program comments are really important because they provide information about the logic of your program, and that's how you communicate with other programmers or other users. Program comments are a piece of program text that the computer ignores but that provides useful documentation to programmers. So we can use end-of-line comments. Begin with the sharp symbol and extend to the end of a line. So it might explain the purpose of a variable or the strategy used by a piece of code. For example, rate, my variable, is equal to 0.85. So I want to know why this rate is 0.85. Then I look at the comment starting with with the sharp symbol. Conversion rate for Canadian to US dollars. Then I understand, okay, this is a conversion rate. So there are some common practices and tips related to comments. Begin a program with a statement of purpose and other information helpful to programmers. For example, your contact information that this program calculates the exponential distribution or generates 100 instances of random numbers. And then accompany a variable definition with a comment that explains the variable's purpose, that why you define these variables. Precede major segments of code with brief comments that explain their purpose. So later on you will have different procedures, different functions. We want to explain that why we define this procedure or how they are linked together. Include comments to explain the workings of complex or tricky sections of code, which is very useful because other programmers understand the logic, our thought process, and why we define the function that way. And here's a note before I move on to the next topic. I do expect all of you to use comments when you are working on your homework assignment and project. That way I can understand what you were trying to do, and we technically communicate through those comments. So let's try to use comments in our assignment and projects, whatever we do in this course. Okay, now moving on to arithmetic expressions. An arithmetic expression consists of operands and operators combined in a manner that is already familiar to you from learning algebra. Here's the table. So we use, for negation, we use minus. For exponentiation, we use double asterisk sign. So a raised to b, so we use 2 asterisk sign. If we have 1 asterisk sign, it's multiplication, a times b. For division, we use a forward slash, a divided by b. For quotient, you have 2 forward slashes. And for remainder, we use the percentage sign. For addition, we use plus sign, and minus for subtraction. I would like for us to review the precedence rules. Most likely you have seen this before, but we just want to review it. Exponentiation has the highest precedence and is evaluated first. Okay. Unary negation is executed next. Multiplication, division, and remainder are evaluated before addition and subtraction. Addition and subtraction are evaluated before equality. So here's a note. With 2 exceptions, operations of equal precedence are left associative. So they are evaluated from left to right. This is just the precedence rules for arithmetic operations that most likely you have seen before. Now, conversion function. Let's say we want to make a number an integer. So we use int, and if you remember, this is one of the data structure. So int 3.77, then the result will be 3. So it drops the fractional values. Or if you have a string, so you have a number, but it's inside a quotation mark. Then you apply int function, then it becomes an integer. Float, so a number becomes float. For example, float 22, then you see a decimal point and a number after the decimal point. And a string makes anything a string. So you will see a single quotation mark. So if you want to multiply 2 numbers, then it should be either integer or float. You cannot multiply 2 strings. Instead, you can join them using plus sign. So note that the int function converts a float to an int by truncation, not by rounding. What does it mean? So if you apply int to 6.75, the result would be 6. So it drops the digit after decimal points. But if you apply round, then it rounded up. Round 6.75, and it's equal to 7. This is a note. Moving on to functions and modules. So you are going to hear modules and functions in programming a lot. Python includes many useful functions which are organized in libraries of code called modules. So here I just want to go over the definitions. So we have some functions. They are all organized in libraries of code, which is called modules. Overall, a function is a chunk of code that can be called by name to perform a task. So I have a function which subtracts 2 numbers. So I call the function, and then I can see it runs the code for us. Functions often require arguments or parameters. So think about a linear function. Y is equal to x plus 2. So we plug in different values for x, and then we calculate y. So oftentimes we require input parameters for function, but it is optional. It's not required. For some function, we don't need any input from the user. When function completes its task, it may return a value back to the part of the program that called it. So later on, we will discuss different functions, recursive functions, and we will elaborate on this. But to learn how to use a function's argument, use the help function. So for example, round is one of the built-in functions, and we want to know what it does. So we can call help round. Let's run this and see what we have here. So help, the color is green, and then round. When I run this, you can see some information about round. So round number of digits. So you can see two input arguments. Round a number to a given precision and decimal digits. So that can be handy when you want to retrieve some information about functions already defined in different modules. So the very first module we discuss in class is math module. So functions and other resources are coded in component called modules, as we discussed before. But the under math modules, we can see where some popular functions like absolute values, round, or different constants that we have seen in algebra or calculus. We can retrieve those functions. So the math module includes functions that perform basic mathematical operations. In the beginning of this lecture, we discussed arithmetic operations. All of those are defined under math module. But here's the point. Given that this is our very first module, we want to know how we can get access to functions under each module. So to use a resource from a module, you write the name of a module as a qualifier. So here, math, for example, followed by a dot and the name of the resource. For example, I want to retrieve the pi value. Pi value is under math module. I call math.pi. Then I'm going to see the result. So here you can see a piece of code that I'm importing pi value from math module, and then I am printing the result. Let's run this in a notebook and see what it looks like. From math import pi. So from and import are reserved words, so the color is green. Okay, I run this. Okay, now we have access to pi. And then I want to print pi. Then the result is 3.1415 and etc. So that's how we import functions from a module. We use from as a reserved word, and then import just to import a function or a constant value. So we learned our very first module in Python, math. ABS and round are also defined under math module. It returns the absolute value or it rounds a number. Now, to summarize the main point for this lecture, the string data type is used to represent text for input and output. So whenever we want to use text, the data structure is a string. We also talked about commenting rules. Comments are pieces of code not evaluated by the interpreter, but can be read by programmers to obtain information about a program. And we want to practice this, so we try to add comments to every piece of code, specifically in our assignment and projects. We also discussed variables. Variables are names that refer to values. So I define different variables because then I just call the variable and then I have access to its value. And the value can get updated over time, for example. We also discussed some data types, integer and float. We discussed arithmetic operators to form arithmetic expressions, and operators are ranked in precedence, and we briefly discussed the precedence rules. We define a function. So a function call consists of a function's name and its arguments or parameter, and it may return a result value to the caller. So when we define a function, we might need some input parameters, but it's not necessarily required. Python is a strongly typed language. It means that it's case sensitive. And a module is a set of resources that can be imported. So we import modules and then we get access to different functions defined under the module. Now here's our review quiz. Here's an assignment for you. I have uploaded a notebook file, taxform.ipynb. So you can see the file extension is ipynb. It means that it's a notebook file. And when you run this code, it throws an error. Now the question is, can you debug this program based on the rules that we have discussed so far, based on the syntax that we have learned? So I would like to show you how you can upload a notebook here. Okay. When you open a Jupyter notebook, then you see this window, and on the right side you will see the upload button. If you click on it, and then you can choose the file that here is the taxform.ipynb, and then you upload it, then you should be able to open it. When I click on it, wrong file. This is the program. So if you remember when we were discussing the commenting rule, I said we always start with some information that what this piece of program is going to do. So program, the name, it computes a person's income tax. So we know that this is the purpose of this algorithm. And here you can see 4 steps. There are like significant constant, which is explained here. The inputs are these 2 inputs. So it means that we are going to ask the user to input these values for us, and then the computation. So based on these input parameters, we are going to calculate net income and income tax. And then the outputs are these 2, the income tax rounded to 2 figures. Okay. And now this is the code. Okay. If you run this, so you can see that I'm defining my variables. First, initialize the constant, and then we are asking the input, asking for inputs. So you can see I'm using the sharp symbol. Okay, now request the inputs. You will see 2 input statements, and then compute the income tax, and then display the income tax. To show the result, we use the print statement. And if you run this, okay, I need to enter the gross income, which is 23, let's say 23K, number of dependent 5, and then we see this error. Now I would like for you to identify or troubleshoot this error, that what is wrong with this piece of code. Hopefully you will figure it out. If you have any difficulties, please connect with me during my office hour, online office hour. And that's it for today.